Hi, this video is to help you in the process of assigning oxidation states to elements and compounds and polyatomic ions and so forth. Now, there are a series of 7 rules that apply to this process, and you should have a copy of those 7 rules in your notes. They also can be found on the lecture slides. And these rules are done in order of precedence. In other words, rule number 1 applies first, and it takes precedence over rule number 2 or 3 or anything else. All right, so we go through with each element and try to figure out what the oxidation state is. Now we'll start off with this compound here. Rule number 1 is for pure elements. There's no pure elements. Rule number 2 says for an ionic compound. All right. Technically, this is an acid, so it doesn't really count as an ionic compound. Rule number 3 applies for oxygen that is connected to non-metals. Well, we have an oxygens here. We have 4 of them, and it says that oxygen is almost always -2. So the oxygen state of oxygen will be -2. Then the next step is rule 4 says that hydrogen is always going to be +1 when attached to nonmetals. So each one of these is +1. So we say hydrogen is +1 oxidation state. And then we can skip down to rule 6, and we use 6 and 7 to figure out what the last remaining one element is, the oxidation state, for the last remaining element, if it doesn't already have an oxidation number. And in this case, we have sulfur. Now, in this rule, rule 6 says that when you add up all the oxidation states, it must equal 0, since this is a compound. Compounds have an overall charge of 0. So we can do this many different ways. You can even do it in your head, but basically what we're doing is we're saying we have 2 positive ones plus whatever sulfur is, we'll say that's an X, and then we have 4 negative 2's. So that 4 times -2, that's going to be a -8. All right. So we have 2 plus what plus -8 equals 0. All right. Well, we can do some simple algebra and say that 2 minus 8 is -6. And we put that on the other side as +6. So X is equal to +6. So sulfur has an oxidation state of +6. All right. So we have now those. Now here we have oxidation numbers for manganese dioxide. First of all, this is not a pure element, but rule number 2, this is an ionic compound. All right. So, oh, and by the way, I forgot to do this. Sorry about that. This is rule number 3. Here, this was rule number 4. And this, we use rule number 6 for. All right. Down here, the manganese and the oxygen, well, this is an ionic compound because manganese is a metal. It's not, and therefore rule number 2 applies, which basically states that the oxidation numbers are going to be equal to the ionic charge of the ions in an ionic compound. So we don't know what manganese is since it's not in columns 1, 2, or 13. We do know that oxygen is going to be -2. All right. And that again is rule number 2. And if that's -2, the whole thing has to equal 0. 2 times -2 is -4, which means that that has to be +4. So the manganese is +4. And again, that is rule number 2, since this is an ionic compound. All right, moving on. Here we have another compound. It's not a pure element, so rule number 1 does not apply. Rule number 2 does not apply because it's not an ionic compound. Carbon is not a metal. And then we go to rule number 3. There's no oxygen, so there's no rule number 3. But rule number 4 does apply because there's hydrogen. Hydrogen's attached to a nonmetal, so that means each hydrogen is plus 1. All right, so hydrogen is plus 1, and that's rule number 4. We then can skip down to rule number 5 and figure out what the carbon is. 6, remember that's going to be plus 6 plus 2 of these guys, all right, 2 of the carbons are going to have to equal 0. So what times 2 plus 6 equals 0? And the answer is negative 3. So each one of those is negative 3. All right, moving down here for the N2O3. Again, we have no rule number 1 because it's not a pure element. Rule number 2 does not apply because it's not an ionic compound. Nitrogen is a nonmetal, so it's not an ionic compound. Rule number 3 does apply because you have oxygen, and therefore it's negative 2. All right, and then we can skip down to rule number, once again, 6 for the nitrogen. And we know that 3 negative 2's is going to have to equal 2 what's? And the answer is going to be positive 3. So again, 2x plus negative 6 equals 0. 2x equals 6. X is equal to positive 3. And again, that's rule number 3. All right. And now for this one, the nitrite ion, rule number 1 does not apply because it is not a pure element. Rule number 2 does not apply because it's not an ionic compound. Notice how this is still a nonmetal. Rule number 3 does apply for oxygen. All right. And therefore it's negative 2. And then we skip down for nitrogen. Instead of going down to rule number 6, this is going to be rule number 7 because this is a polyatomic ion. The whole thing has a charge. So basically, it's like rule 6, but instead of equals 0, the whole thing, when you add it up, has to equal the ionic charge. So we have nitrogen, which is only one of those, plus 2 negative 2's, so that's negative 4, has to be equal to negative 1. Well, x plus negative 4 equals negative 1. That means the x has to be a positive 3. Since we add 4 to both sides, we get positive 3. And then finally, down here with F2, finally we get to use rule number 1 because this is a pure element. It's not attached to any other element. Therefore, F is equal to 0. And that's how you find the oxidation states. Now, if this were a chemical reaction and you need to figure out, well, what is oxidizing and what is reducing, then it is a simple matter of assigning the oxidation numbers and seeing, well, what goes up and what goes down. So if we're looking at chemical reactions, let's just do a simple one. C2H6 plus O2 reacts to form CO2 and H2O. We don't even need to balance it, all right? We just need to assign oxidation numbers. Rule number 1, oxygen's by itself, so it's 0. There's no rule number 2 because there's no ionic compounds. Rule number 3 is all these oxygens over here are each negative 2. Rule number 4 says this hydrogen is plus 1. And then we can go down to rule number 6 and say, well, what this carbon if the whole has to be what charge in order to the whole thing has to be equal to 0. So 2 times what plus 6 equals 0, and the answer is negative 3. All right, so that's going to be a negative 3 charge. Going back over here, we have carbon going, and it is 2, -2, so that's going to be a +4. And hydrogen, I forgot, it's still going to be a +1. So if we notice, carbon is going from -3 to +4. So that means that carbon is oxidizing. And we would say that oxygen is going from 0 down to -2. So oxygen is reducing. And if we throw oxidizing and reducing agents in there, then it's just a simple matter of saying that carbon is part of this reactant. So if it's oxidizing, that means this is the reducing agent, the whole compound. And if O is reducing, that means this is the oxidizing agent. But the key thing is you have to figure out what is oxidizing and what is reducing. And if you have any additional questions, make sure you ask me during tutorial. Good luck.